This is the next part of our DevOps learning series, Databases in DevOps. Let's jump right in. Introduction to DML. We're exploring DML, Data Manipulation Language. DML is the part of SQL that lets us insert, update, delete, and retrieve data from a database. It's essential because data constantly evolves with real-world changes. Whether you're adding new records, modifying existing ones, or removing outdated entries, DML gives you the tools to manage it all efficiently. Let's dive into how these operations keep our databases dynamic and relevant. Let's talk about the SQL Select query, one of the most powerful tools in your database toolkit. Select is a DML command used to retrieve rows from a table. The result is a set of data neatly returned as a table. The basic syntax is simple. Select the columns you want from the table you need, and optionally filter with a where clause. It's the foundation of querying, precise, flexible, and essential for data analysis. Look at a simple SQL query in the context of a boat reservation system. We have three tables: sailor, boat, and reserves. The query, selects name, rating from sailor, retrieves the names and ratings of all sailors. This is a basic select statement that pulls specific columns from the sailor table, returning a result set in tabular form. It's a great example of how SQL helps us extract meaningful data from structured tables. Some key SQL clauses that shape your queries. Distinct removes duplicate rows, from tells SQL which table to pull data from, where filters rows based on conditions, and order by sorts the results. Together, they help you write precise and powerful queries. The typical order is select, from, where, then order by. How select clauses work in SQL. When you use select rating from sailor, it returns all ratings, including duplicates. But if you want only unique ratings, use select distinct rating from sailor. Distinct filters out repeated values, giving you a cleaner result set. This is especially useful when analyzing categories or summarizing data. Let's dive into the SQL where clause. It helps us filter rows based on specific conditions, so instead of retrieving everything, we get just what we need. You can use arithmetic, comparison, and logical operators to build powerful expressions. For example, filter sailors by age, rating, or even match patterns using like. This is how SQL becomes precise and dynamic. SQL comparison operators. These are essential for filtering data in queries. You've got basics like equals, not equals, and greater or less than signs. For ranges, use comma, and to handle nulls safely, use dot. These operators help you define precise conditions in your clause, making your queries smarter and more targeted. Logical operators in SQL. These help us combine multiple conditions in a where clause. Use and when all conditions must be true, or when any condition can be true, XOR for exclusive cases, and not to negate a condition. You can also use in for cleaner comparisons and is null to check for missing values. These tools make your queries smarter and more flexible. Look at how the clause works with different operators. First, using colon, we can filter sailors whose age matches any value in a list, like 26, 35, or 45. It's clean and efficient. Next, we combine conditions using and. For example, we can select sailors older than 30 whose rating is either 3 or 8. These operators help us build precise filters to extract just the data we need. 2 essential SQL operations. First, select with order by. This lets us sort query results like arranging sailor names alphabetically. It's great for organizing output. Second, the insert statement, used to add new records into a table. Just match the column list with the values list, and SQL takes care of the rest. Together, these commands help us manage and structure data effectively. 2 key SQL commands. First, used to add new records into a table. Just match the column list with the values list, and SQL will insert the data. Second, this clause lets us sort query results, like arranging names alphabetically. Together, these commands help us build and organize our database efficiently. Let's talk about the SQL update statement. It's used to modify existing rows in a table. You specify the column to change using the SETI clause and use where to target specific rows. For example, updating an order number for a given order ID. It's a powerful way to keep your data accurate and up to date. The SQL statement. This command removes entire rows from a table, not just individual values. You use to specify which row to delete. For example, deleting an order with ID 200. It's a powerful tool, so always double-check your condition before executing. DCL Data Control Language. DCL Data Control Language is a subset of SQL used to control data access and enforce security through commands like grant, provide access permissions, revoke, remove permissions, deny, block unauthorized actions. DCL, it's used to manage access privileges in a database. With, you give users permission to perform actions like creating tables. With, you take those permissions back. These commands help maintain security and control over who can do what in your database environment. Let's talk about database permissions. SQL uses to give users access, like allowing them to select, insert, or drop tables. For example, you can grant drop privileges on a database to a user. If needed, you can take those permissions back using dot. Managing privileges ensures your database stays secure and well controlled. SQL joins, essential for combining data across multiple tables. When one table isn't enough, joins help us answer complex questions. Returns matching rows from both tables. Keeps all rows from the left table, even if there's no match. Does the same for the right table, and pairs every row from one table with every row from another. These joins unlock the full power of relational databases. Inner join in SQL. When we need data from two tables like employee details and their addresses, inner join helps us combine them, matching rows where a common column, like EMPID, exists in both. The result includes only those employees who have a corresponding address entry. It's perfect for merging related data across tables. Here's the result of our inner join between the employee and address tables. We matched rows where EMPID exists in both tables. The output shows only those employees, like 1002 and 1003, who have corresponding address entries. This is the power of inner join. It filters and combines data precisely where relationships exist. Let's clarify cross-join versus inner join. A cross-join returns every possible combination of rows from two tables, so if one table has 3 rows and the other has 3, the result will have 9 rows. It's like pairing every product with every company. In contrast, an inner join returns only matching rows based on a condition, like shared company ID. Use cross-join when you want all combinations, and inner join when you want meaningful matches. Here's what a cross-join looks like in action. Every product is paired with every company, regardless of any matching condition. So with 3 products and 3 companies, we get 9 combinations. This is useful when exploring all possible pairings, like testing compatibility or generating combinations for analysis. Let's walk through installing MySQL on a Debian-based system. First, update and upgrade your packages. Then download the MySQL and install it. Check out the steps to ensure your system is ready for secure and reliable database operations. After installing MySQL, it's time to secure it. Run MySQL Secure Installation to configure key safety settings. Say yes to removing anonymous users, disabling remote root login, deleting the test database, and reloading privileges. These steps protect your server from unauthorized access and keep your data safe. MySQL setup. First, create a new user with a secure password, then grant privileges so they can manage the database. Don't forget to flush privileges to apply changes. For remote access, edit the MySQL config file and set bind address to 0.0.0.0. This opens MySQL to external connections. Just be sure to secure it properly. To allow MySQL access from any network, grant privileges using root%. Then update the user's host to % and re-authenticate with a secure password. This opens global access, but be cautious. It's best to restrict connections to trusted IPs, even in development environments, to keep your database secure. PostgreSQL is an advanced enterprise-class and open-source relational database system. PostgreSQL supports both SQL, relational, and JSON, non-relational, querying. PostgreSQL is a highly stable database backed by more than 20 years of development by the open-source community. Let's install PostgreSQL on a Debian-based system. First, fetch the repository key and add the PostgreSQL source to your system. Then install PostgreSQL and its client. Switch to the Postgres user, set a strong password, and enter the database using PSQL. These steps get your PostgreSQL server up and running securely. To enable remote access in PostgreSQL, update the PostgreSQL.conf file by setting listen addresses to *. Then restart the PostgreSQL service. Next, configure pghba.conf. This file controls who can connect. Add entries to allow all users from any IP using password authentication. These steps open your database to remote connections, but always secure it with strong access policies. A database dump is a snapshot of your database, structure, and data exported into a single file. It's perfect for backups or migrations. First, create your database and table, then insert some data. Finally, use MySQL dump to export everything into a .sql file. This file can be restored later to recreate your database exactly as it was. Let's talk about backing up and restoring MySQL databases. Use MySQL dump to export all databases or specific ones into a .sql file. This file captures both structure and data. To restore, use the musl command and point it to your backup file. These steps are essential for disaster recovery and data migration. In PostgreSQL, a database dump is a way to export your data and schema into a file for backup or migration. Use pgddump to create the dump and pgdrestore to bring it back. PostgreSQL also supports different architecture tiers: 1-tier for standalone setups, 2-tier for client-server models, and 3-tier for scalable distributed systems. Understanding these tiers helps you design robust database solutions. In PostgreSQL, a database dump lets you export your data and schema for backup or migration. Use pgdump with credentials and connection details to create the dump file. To restore, use pgrestore and point it to your target database. Understanding architecture tiers, like 1-tier for standalone setups, 2-tier for client-server models, and 3-tier for scalable web apps, helps you design efficient database systems. MongoDB is a modern NoSQL database built for flexibility and scale. It stores data in JSON-like documents, making it ideal for unstructured or semi-structured data. To install it on Debian-based systems, first import the GPG key, then add the MongoDB repository. Update your package list and install MongoDB. Finally, start and enable the service to get your database up and running. To install MongoDB on Red Hat-based systems like RHEL or Red Hat Base, start by creating the repository file with the correct base URL and GPG key, then install MongoDB using yum. Finally, start and enable the MongoDB service so MongoDB runs automatically. These steps prepare your system for scalable, document-based data storage. After installing MongoDB, it's time to secure and configure it. First, bind the IP to allow remote access if needed, then enable authentication to protect your data. Create an admin user with appropriate roles using Mongosh. Finally, open port 27017 in your firewall to allow connections. These steps ensure your MongoDB server is both accessible and secure. As a concluding note, you don't just store data, you safeguard decisions, power applications, and keep the digital world running. Every query you optimize, every backup you secure, every failure you prevent, it's silent brilliance that drives everything forward. Thank you for your attention, subscribe to our channel, and never miss a weekly tech episode.